Hello, today I'm continuing the last lecture with regard to the laboratory genomics. To start with, I need to start Python. Is that right? Okay. So I will go to super user using sudo bash. Let me go to mount, and I plant was my main directory. So I need to run Python lab actually, and allow root to give them the root permission to the Jupyter lab. Okay. For a while, wait for a while, and it will gives you the URL and copy to the your web browser, Google Chrome, for example. Then you will see the opening page of Jupyter with doc tema. Then now you can see the last code that we made here. So I will, because you open this code again, so you have to learn it all again to copy the information to your memory. Then you will see some your number changed to 1. Learn this number changed to 2. Learn everything. So maybe I need to explain once again for you guys to understand the logic of this code, but I need to wait for a while to upload every information into memory. So this field circle indicates you that this corner is busy. Okay, you can see the message corner busy. So corner busy means actually this Jupyter is working. Okay, so it's done. Then it become idle, right? So I will learn everything again. Okay. Then now I have everything that I made last lecture. So what we have dictionary of pasta. The pasta information. Pasta means the sequence, right? The sequence of laboratory. So this file was the laboratory genome sequence, and this one is gene model, laboratory gene model. So we have gene model of laboratory and sequence of laboratory. Actually, that is all we need. So recently, I received some requests to teach how to extract the promoter region of certain gene. Then so I will label here retrieving promoter region. So usually for the main model organisms such as a human or autopsies or mouse, maybe there is a lot of database that already have the promoter region sequences. However, if you are dealing with the orphan crop such as rubber tree or dogweed or oil tree, palm tree, then you will not have any information of a promoter region because people are not that I would say well developed the database yet, because there is not enough bioinformatician or there is no niche yet because nobody actually care the promoter region yet. So if you are asking where is the promoter, what is the promoter region sequences, then maybe you are the first one, the first one studying the promoter region. That means you have to retrieve the promoter region, right? So you have to find the promoter region, the location from gene model. So again, let's open the gene model. Okay, then again you can see the mRNA here. The second column gives you mRNA and the strand, right? So 2 and 6 is very important to extract the promoter region. So let's filter mRNA first. mRNA first. Maybe last time you already done, but I will do it again for you guys understand more clearly. RNA, gene model, M, right? Then now we have mRNA data frame. Okay, maybe you already noticed that your starting point of gene will be this one, right? Because this is plus strand. So this is the starting point. But in the case of this, your starting point will be this because this is minus strand. Let me deal with the plus strand. Okay, so I will just use this number manually. The starting point is this one. And your config number is this one, right? Config ID, I will say. Config ID. Then you can use dictionary. Config ID. Then you will have sequences. So it gives you a lot of sequences. Sorry. A lot of sequences. And your starting point is this. Right? But the problem is you have to know that this starting point using one based numbering scheme, okay, but in Python using zero based numbering scheme, which means if you are talking about one using one based numbering scheme, then you have to put 0 for zero based numbering scheme, which means you have to put -1. Okay, so we can easily maybe we can easily inspect our scheme using this one 2, this one plus some plus 3. Okay, so we can inspect the starting codon is ATG. Okay, it gives you back ATG. So maybe this is really the upstream. I mean starting point, right? Then what is your upstream? So upstream with maybe with. So you want extract 5k, no, just 500. So 500 basis is upstream. You are thinking. Then dictionary pasta config id this one to this one, right? To this one starting minus upstream with right? Okay, then this is the upstream. Okay, this is the upstream sequences. This is the upstream. Easy, very easy. So this is the manual way we have done. So let's make I want to make definition function. How do you make function? I will comment out this testing command. I'm leaving all these parametric variables, and I will define this one as get upstream. Okay, good. So get upstream require starting point. Okay. Then maybe I have to change this value. Starting point, and maybe I will put this config id, right? Comment this out. So upstream width is maybe you also put here. You also determine upstream width here, but I will put this the default value as 500 like this. Then everything is well sorted. Okay, then return upstream sequences. Get upstream. Then the problem is we are talking about just plus trend, so I will yeah. Let's test one more things here. Strand. I will put strand. So if the strand equal plus else, upstream sequences should be something different. But I will. Your starting point is not that one. Okay. Then I will put here end point. So your if the strand is minus, then this one will be the starting point, is it right? So then this is end point. So I will say here end point. So endpoint minus 1 will be this is bit confusing. Okay, then I will test it first. So this is a starting point. This one. So config id will be this one. No. Okay, then dictionary pasta content ID starting point. Let's see. Okay, that is C. This is confusing because this is minus trend. So what is the really starting point for ATG? Because this is base one based scheme, but this should be zero based scheme. So what is your suggestion? So zero based scheme should be this. I'm thinking then you should plus 1 ATG plus 2 ATG minus 1 AT, but this should be reverse starting point minus 1 plus 1 TGA. This is weird. Okay. Starting point. Let me calculate for a while. Reverse transcript TAC. TAC가 돼야 되고, 그리고 여기에 넘버가 있으면 는 9에서 10까지 가는 거죠. 오케이. 자, 그러면 다시 가겠습니다. 스타팅 포인트에서 스타팅 포인트 마이너스 4. 오케이. 그럼 ATG 오케이 그렇죠? ATG reverse in the case of the reverse transcription, then it become ATG. Okay. So what is the happening? So this is hard to explain. So your sequence is going to in reverse way, and for example, okay, gives you 6-1, then CTG, CAT, right? Then these numbers will be one based scheme, but your zero based scheme need to be -1, 그렇죠? require -1, but you have to cover these numbers, right? These bases. Then you have to indicate like this. You have to indicate this number as ending point to cover these values. So your starting point should be like this, not -1. Rather, your actual ending point will be -3 because your codon is always have 3 letters. This is the confusing, but if you have more question, I will explain with writings. Okay. So this is the inspection. This is the inspection to gives you CAT in reverse way. Then it is true. Okay. So it is okay. But the problem is we have to reverse transcribe, reverse complement sequences. So how do you make a reverse complement sequences? That is for that use dictionary. A should be T, A should T, T should A, G should be C for reverse complement, C should G, is that right? And if you have missing data N goes to N. So this is this dictionary for the reverse transcription. So I will make this left. No, complementary, right? Okay, you have test sequence such as ATG, okay. Then how do you reverse transcribe? First you have to reverse. This is reverse, right? And all these sequences should be reversed. Let me check if this string doesn't have any map. Then how about list? List objects don't have map. Then what kind of object have a map? Map. Hold on. List. I'm confusing. Okay. Let me just use for in test sequence. Okay. The comp. This should this one I. Okay. Live comp. Live comp and live comp. Then okay, now we have reverse complementary sequences. Then let's join everything. Then okay, we have reverse complementary. So everything should be parsed into what? Again, definition. Lab comp. Get lab comp and sequences. Then this test sequence should go somewhere, and this should seek, and you will return. Then you have very good definition. Get lab comp. Actually, I want to use map, but I don't know why they don't have a map. Okay, good. So very good. So then how? What is the upstream? What is the upstream? Then the config ID starting point. So this is the actually the exact ending point, right? I mean starting point. So I will just starting point plus plus upstream with. Right? Okay. Then this is the upstream sequence. However, what we have to do is get lab comp. Oh my, what is the problem? 9%. Yes, because we don't put any information for the small case letter, so we have to change the sequence into the uppercase. Is upper. Right? Then upstream sequence. Then you have reverse complementary upstream sequences. Okay, and I will merge this. I will merge this information to here. So upstream sequence, right? Okay. So this is not starting point. You should check. Change endpoint. Endpoint. This is starting point, this is end point. It's a little confusing, but please observe more carefully and understand what I'm saying. Upstream, end point, upstream with. So if your strand is plus, then you will retrieve the starting point based on the starting point, this value, okay? Else, what is else? The strand is minus. Then you will select endpoint, right? And upstream with and reverse complement. Then what is the problem? Get upstream config ID. Non-default argument. So we have to put strand here. Strand here. Okay, right? So then using this, so everything we test. Oh no. So this is the definition we made. So we keep this definition here. Okay. This is definition for getting reverse complementary sequence. Okay. Then data frame mRNA we have. Let's make upstream promoter region. Okay. Gene model mRNA. And what do you need? Apply and lambda. Okay, so what does it mean? What does it mean? This means you use information of this data frame, and the information goes to this lambda function, and how it goes, x is 1. So if you put x is 1, then row by row information goes to lambda x. Then you can select 3, right? 3 as starting point. So get upstream, right? So what is the first one? The config ID. So this is 0. What is the second one? Starting point. Starting point should be 3. Ending point should be 4. And strand. What is strand? 6. 6. Okay. Close. So we just put upstream width as 500. This is default value, so we don't need to put any word here. So let's enter. No, what happened? local variable, upstream sequences, reference before. Okay, put S. No. And for a while. Okay, it's done. Let's check. In model mRNA. And now you have promoter regions, right? You have promoter regions. So you don't need to do this manually. But what you have to really do is, what you really have to do is sanity check. So please check if this is really right, because everything have done using using your code. So sometimes you will have unexpected errors. So this is we usually call logical error. So we were thinking that everything is perfect, but sometimes it is not perfect. So you have to check sometimes manually. For example, you have to pick 10 examples from randomly, then check if it is really right. So this is interesting because sometimes something is really similar to each other. So maybe you can cluster those sequences whether it is associated each other, because sometimes the protein DNA binding boxes well conserved each other. So people really check whether these sequences or box sequences are well conserved or linked to each other or not. If the box is shared, for example, for two genes, then these two different genes can be controlled by one protein, which directly bind to the box, right? So this is how you create promoter region manually, I know, using code rather than using a well-established database. This is really important for the industrial plant or open crops that doesn't have any information or well constructed database. Okay, that's it for now. See you again